Albert Camus once said, "An intellectual is someone whose mind watches itself." It's called metacognition. The initial idea is that you're intelligent because you're able to think about your own thoughts. Today, I would like to test what happens if you pass the same data twice through a neural network. Now, neural networks is just a mathematical function which multiplies data with weights, and data and weights are just a bunch of numbers, except the data remains locked and weights change over time to produce better output. Groups of weights result in a layer, and you can stack these layers up, which result in a deep neural network, which these large companies use to create large language models. We can't do that because we need memory. So I'm thinking, what if I can reuse the layer that way, save the memory? And to do that, I need to write my own neural network, which I kind of forgot how to do. Fortunately, there's this library called PyTorch written by smart people, and I can just. Now, a second problem is that I need data. A while ago, I heard about this dataset called CIFAR-10, which I believe is 60,000 images, and they belong to 10 different categories. And then, given an image, our neural network has to predict which type the image belongs to. Fortunately for us, PyTorch provides this dataset, and then I just need to build a neural network. And once we run the code, we get an error. It's because the image is in RGB, which means they have 3 different lists, and for each pixel, each list has respective values. The first list has red, the second list has green, and the third list has blue. Unfortunately, our linear layer is too stupid to figure that out. We need to take these colors and store it in one list. Now, to do that, there's a technique called flattening. Fortunately, PyTorch provides that. So let me flatten the image and try training it again. This time it works. I have 3 neural networks. Brain small, which is what a beginner would do. It only has an input and an output layer. Then I have brain big. I just added one layer in the middle. It's called a hidden layer, just because it's in the middle. And then I have brain test, which is a copy of brain small, except it processes the data twice before learning. And during training, we can see that brain small already learns much slower than the other two. And in testing, the accuracy of brain big and brain test have about the same result. So it is possible to save memory in neural networks.